So a very warm welcome to SupraChem Disc 2024. We have organized this meeting. This is a discussion meeting and it encourages the young people who are active in this region of the country, that is Kolkata and West Bengal, that who are working continuously, excelling in the study of interactions between the molecules and in making of the materials. And they are concerned, or their studies are concerned with the study of bonds beyond molecules. Those are the supramolecular interactions. And we have representation from all the nice institutes of this region, of course from IISER Kolkata, from IISER Kolkata, from SN Bose, Calcutta University, Jaipur University, and so on and so forth. So I hope that you will enjoy the short video that my students have prepared, and they have curated it for you just to give you an overview and a sneak peek into the program. So I hope you enjoy this. Thank you very much.
That include generating a green energy, climate actions, protecting the environment, and making the people life healthy and prosperous by 2030. As I am coming from eco-friendly applied material laboratory, we always think to develop a technology that is sustainable and green. So coming to the soft oxometalate, crafting the pillar of the sustainable future. What is soft oxometalate? It is the extensive condensation of metal oxo salt lead to the formation of extended network in the dispersion commonly known as the colloidal state of oxometalates. In oxometalates chemistry, there are lots of evidences we have got that exist that state that it has a that indicates that it have a soft colloidal phase. Like other soft oxometalates or soft matter, it has a diffuse mobile boundary and also it scatters light. So due to a soft nature, it is a great platform to understand the crystallization from colloidal phase. As in our lab, we
Next, the assay for the ROS generation. For the ROS generation assay, we have used the DPBA. DPBA is a dye which absorbance is gradually decreases as 419 nanometer upon irradiation of the with the ruthenium nap also. It shows that it can form the singlet oxygen or several other reactive oxygen species. So this is the general assay for the DPBA. Now we have detected which one is the specific for here, the singlet oxygen or other assays. Then we choose the ABDA. ABDA is specific for the singlet oxygen only, and the absorbance of the ABDA is gradually decreases upon photoirradiation here. Next we check what is the fate of molecule with the microtubule. The ruthenium NAP, it promotes the microtubule assembly or the microtubule polymerization, and NAP also promotes the microtubule polymerization also. Like the literature report shows the mechanism pathway of the paclitaxel, it can promote the microtubule and lead the apoptosis here. So ruthenium NAP also adapt here the same type of mechanism also. Then we perform the biophysical assay for the tryptophan coenzyme. The microtubule, in the structure of microtubule there is the several tryptophan coenzyme. Any agent that can bind with the microtubule, then the fluorescence response of tryptophan is gradually quenched. And based on this, we have calculated the binding constant of the NAP and the ruthenium NAP. Here we found that ruthenium NAP binds more favorably rather than the NAP towards the tubulin, because in the microtubule structure there is several carboxylate moiety also from the glutamate residue. And cation
is able to do something which is usually not done in my lab. So this is hardcore interdisciplinary work. I am from experimental physics background, working with a chemist. So it's
working on biology.
I'm working on biology. So yes. So and Professor Somajit sir, Rakesh da means he was a Somajit sir is like means co-guide to me. So he guides me in lot of other means most of the work is, I think my sir and Somajit sir are I talk at some point of time I have talked to him more than my sir. So means yes, I and Rakesh Da means Somajit sir's student only, and Kokan is here only. So
Kokan is here.
yes. So and Amirul sir means helped us in since we don't have the bio clearance. So he has all the bio clearance for using H1N1 or E. coli. And Sucharita is also she helps with the bacterial and viral samples. So thank you. Any questions?
And another paper from Mirabat group, and where they use this hydrogenator and catalyze this reaction, this algal reaction, and they got the selectively this product in the hydrogen medium. Now, coming to in our recent work, the supramolecular gel indicate oxygen permutation and facilitate air-sensitive intermolecular diametric 4+2 cycloaddition of naphthalene by visible light energy transfer catalysis. According to Gorius, most of the energy transfer catalysis reactions need an oxygen-free environment. Because if you can see the Jevons tree diagram, when we irradiated the photosensitive area, then in the electron goes to ground state to excitation, and intersection crossing it goes to
hydrophobic in nature. ILCS1, which has one methyl group, is highly hydrophilic in nature, and the remaining two catalysts were moderately hydrophobic in nature. To our surprise, here we noted that the hydrophobicity trend of this material exactly matches with the catalytic activity trend, indicating that it's the hydrophobic nature of this material which play a predominant role in facilitating the reaction of non-polar epoxide. So now, knowing the reason behind higher activity of ILCS8, ILCS8 was chosen as a model catalyst and other optimization studies were performed. Under the optimized reaction condition, this many cyclic carbonates were successfully synthesized, and it should be noted that all the reactions are performed at 1 bar CO2 pressure. Then to check the robustness of material, recyclability experiment was performed, where it was noted that with each cycle catalyst loses catalytic activity. So then to understand why there was a loss in catalytic activity, the recycled material was characterized using different techniques. And from FTIR analysis, we noted that the intensity of bands corresponding to ionic liquid functionalities has decreased considerably upon the recyclability experiment. This indicates that during this recyclability study, the ionic liquid is getting leached from our catalyst, and that's why the catalytic activity decreases. So, in conclusion, we have prepared a series of ionic liquid grafted ketose and
and 93% yield in asymmetric excess of that epoxy compound. After that, our target is to cyclize the compound. So for that purpose, we have charged various Lewis acid such as T tetrachloride, BF3 etherate, and copper triplet, zinc triplet. And we got the better result when we have used the titanium tetrachloride as a Lewis acid. And so here I have shown the plausible transition state. At first, this Lewis acid coordinate with this epoxide oxygen as well as this alcoholic group and activate this carbon center, and followed by the adjacent olefin unit attack over here, followed by the aromatic electrophilic addition to give rise the cyclized products, as well as one incomplete cyclized which we got as a minor product.
With increasing the pH, the zeta potential value is shifted from highly positive to negative. That we see at pH around 3, the zeta potential value is highly positive, whereas at pH around 9, the zeta potential value is highly negative. So this synthesized co-assembled vesicle is charge switchable in nature also. And after that, there is a question: if we see some self-assembly of this individual amphiphilic polymer, we have also performed this control study. So for this P2 and P2 dash, we are getting this distinct micellar structure with a unimodal distribution of hydrodynamic diameter also. And for zeta potential measurement, we are getting the positive and negatively charged surface for both these polymer at pH 7.4. Now, if we tune the surface charge of this vesicle by changing the pH of the medium, we look there any morphological change occurs or not. So that's why this is the co-assembled structure. We have chosen to extreme condition at pH 4 and pH 9. At pH 4, this morphology of vesicle, there is a conversion from vesicle to spherical aggregates, and that's why we are getting the much deviation of the hydrodynamic diameter from these vesicles. And also it shows distinct spherical aggregates from these TEM images. So there will be the question, that means this negatively charged carboxylate species that could be protonated and perform strong interaction with this NH class moiety of this another polymer, and this structure gets also more packed structure, and that's why their size is decreased. Another extreme condition at pH 9, we are also seeing this kind of similar morphological transition from vesicular structure to micelles, and also this phenomenon is ascertained by DLS analysis and TM analysis. As we
Morning all. So I will be talking about iron 3 hydroperoxide intermediate which forms during oxygen reduction by a thiazide ligated hydroxide complex and would achieve the catalytic aldehyde decarbonization via carboxyl intermediate. So before going into my work, I would like to briefly tell about the kind of what we do in our lab. So we are basically inorganic chemistry group. We make synthetic model complex which mimics the active site structure of different enzymes, metal enzymes, and then we use this to check the functional and structural mimic, whether they can mimic of the active sites of different enzymes. So talking about enzymes. Heme enzymes actually differ in their active site structure, but all of them contains the protoporphyrin, iron protoporphyrin at the active site, which has the structure something like this. But they actually differ in the primary structure of the heme, in the axial coordination of the iron, and in the distal superstructure. So first I will talk about the primary structure. Depending upon the primary structure, that is the substitution at this alpha, beta, gamma, delta, and other beta fuelic position, they can be classified as heme A, B, C, and O. Also, even if the heme primary structure, that is protoporphyrin structure, is same, there can be different residue that actually coordinate with this iron, depending upon, for example, histidine is coordinated in hemoglobin, myoglobin, peroxidate, and threonine is coordinated in.
Molecule also confirmed by the PXRD analysis. The dehydrated framework with one directional void channel exhibit the CO2 uptake of 200 cc per gram and increase of the CO2 uptake from the 34 cc per gram due to the incorporation of the NHCO2. There is almost 6 times enhancement of the CO2 uptake. Why 6 times enhancement of the CO2 uptake? The percentage orientation of the acylamide functional group strongly interact with the carbon dioxide of the carbon dioxide molecule and show the high CO2 uptake. Not only the high CO2 uptake, this material also exhibit the reusability toward the CO2 uptake at 195 K and 1 year. Beyond this CO2 uptake, our group also focus on the another topic of excited state intermolecular proton transfer based sensing by using the 2,5-DHT ligand. The 2,5-DHT ligand can exist in both the keto and enol form or only in the enol form, depending upon the specific base molecule. When it exists in both the keto and enol form, it shows the dual emissive nature, one for keto emission and another.
That's the general question I'm asking. I'll narrow down the problem a bit. I'll be talking about in water only system, even narrower for ice water systems. So ice water is like a essential substance for life, for molecular dynamic simulation. You need to have water to solve your system. But water is pretty complicated. There are a lot of models that kind of target towards specific properties of water. Then there are anomalous properties of water. Water is pretty much complicated. Adding extra layer of complexity is this ice form of water. there are more than 20 form of ICE polymers experimentally verified, and many are theoretically proposed following some rule, say ICE rule. Now, all of them form at different thermodynamic equilibria, and they all are geometrically at least different. That's what I am concerned about. Their properties are also different, but at least they are geometrically different.
Hello, sir. So, please tell us about how was your experience in this conference?
Oh, so far my experience has been really wonderful. I listened to 6 presentations so far made by very young researchers, and all of them, each one of them presented his or her work very nicely, just like a seasoned speaker. And I also, through careful listening to their presentation, I also got to understand and learn a few things from their presentation. That is the best part. And they all, seem to be very enthusiastic about their own work, and they took it in the right spirit that they will present it in front of the audience and look forward for useful interaction, maybe some good suggestions as well as criticisms, which are essential in this kind of a study, active research work. So I believe that this small discussion meeting, small in terms of the duration, it's only one-day meeting, but in terms of the usefulness, it's really great, and I like to convey through you my heartfelt thanks to Professor Soumyajit Rai, who took all the trouble to organize this interaction meeting here at IISER Kolkata. Thank you so much.
Hello, sir. Good morning. Sir, please tell us about your experience in India and the experience you had today in this conference.
Yes, these are of course 2 very different questions. I'm staying here for the first time in India, have already visited other part of the country, and so I can compare, and I'm very impressed by the different kind of ways the daily life works in India. Yeah. And here, of course, this meeting is very nice because it's a nice opportunity for a European professor to get in direct contact with PhD students. And so far I was very impressed about the broadness of the topics and the quality of the topics the students were presenting. Very
Thank
nice.
you so much, sir. Sir, I'm an undergraduate student, sir. So I want to ask you, sir, what is your suggestion to the people who are very new to research, who are currently in the initial stage of their undergraduate degree or masters, or very initial stage of their doctoral studies?
What kind of advice do you mean?
Sir, advice in the sense, sir, how should they approach towards a problem, or what kind of motivation they should maintain?
Yeah, I mean, this is something, there's a point I would like to make because I think most research here goes very quickly into a very applied direction. But before really finding a good solution for an application, even at industrial scale, I think you really have to know the basic science. And don't throw away too early the fundamental sciences. The fundamental sciences are the solution not for tomorrow, but for the next years to come. And you never know what will happen in the next decades. An immediate solution might not be the best solution for the problems that will come up in 20 or 30 years. So fundamental science is very important.
Thank you very much, sir. And you being a very senior person in this field, very experienced person in this field, sir, what is your philosophy of solving a problem, and what is the thing that you have followed all throughout your life? So please enlighten about.
Make use now of the fantastic tools that are available to do literature research. When I was young, I had to sit over the whole weekend in the library to review 5 to 10 papers, and it took hours to find them in the printed books. Now you have all these fancy things. Google Scholar even, you don't have to go to Web of Science or so. Even Google Scholar provides a lot of information and you should screen the databases in detail before. Try to have a look at the problem from different point of views, from different sides, and then you make up your mind and try to figure out the best solution that fits also your interest.
Thank you so much, sir. Thank you so much for talking to us.
Okay.
Have a great day, sir.
Okay, thank you very much for inviting me. To appear on a Sunday, I must confess that it would be very hard to convince German students nowadays to come on Sundays and stay there for the whole day long. I mean, Jake, you have set up this little workshop about supramolecular chemistry. I'm not convinced that all topics did fit perfectly into the definition of supramolecular chemistry. You know, this is supramolecular chemistry is about non-covalent interactions. But I mean, this probably shows also how creative this environment is. I think you also all performed very well. Very nice presentations. Maybe some advices from a senior researcher from my side I might still give. So if you give longer presentation, and I considered 20-25 minutes already a long presentation, perhaps avoid writing whole sentences on the slides. Try to make only a few points, because you will give the sentences anyway, yeah? So you don't have to read. And of course, it was a little bit unfortunate for the presenter today that the laser pointer was not seen, which is a technical problem, I think, by the OLED screen.
Digital screen, it doesn't work.
Yeah. This is always the same. Yeah, I also assume that. Otherwise, I would like to thank you again for giving me the opportunity to take part here in this little workshop. And since I'm still here a few days, so anybody who would like to approach me, I will come to IISER on Wednesday. On Tuesday, giving a presentation on Wednesday. Maybe some of you will join the meeting and the talk there. It would be a pleasure for me to receive also some questions from your side. You can then ask the same nasty question as I was asking. So thank you very much again.
Any second time, because all of you and with your supervisors, you spontaneously agreed. So this shows also the purpose was not really only supramolecular chemistry, as they have pointed it out. The purpose was to showcase the high level of science that is done in and around Calcutta. So that's why I chose also few representation from cultivation and SN Bose, and of course IISER Kolkata dominated. So I would also like to thank, for example, the Sincil for really sponsoring the lunch, which you all liked, as I understand, and also Minakshi for the sponsoring the gifts or whatever you got. So, and IISER Kolkata for the extreme support. We are using the facility of IISER Kolkata and the guest house facility and all. And thank you, all of you. I really appreciate your lecture, your talk, and for coming and spending the whole day with us. I hope you also enjoy. Thank you very much. Sorry, yes, this is why I hate vote of thanks thing, because you forget. Thanks, Venkat. So I also want to thank my group, who have worked extremely hard. So all of them have worked extremely hard for making this a very smooth operation. And you may have received also emails from them and things like that. So this has been done extremely well by all my students, and they are also working hard around in the background. So a big hand of applause for them. Thank you. Have a safe trip back to IISER. Thank you.